Hello all, welcome to the webinar chapter 2 of OpenAir Interface. So we will be talking about the 3GPP specification for the core network. So the agenda for today's webinar is we will cover in 3 parts. So first part we will see about the overview of 3GPP specification for core network, especially some challenges, then the recommended practice for it. Then in second part, we will see some of the implementation specific things with OpenAir interface, like how we can implement some of the procedures and protocols from 3GPP. We will see some of the aspects from the from the coding perspective. And in the third part, we will see the actual example. So we'll try to see example of Pfcp protocol. If possible, we can also cover another protocol like GTP1U or if time permits. So let's start. Let's start the part 1. So the 3GPP it stands for Third Generation Partnership Project. It produces the technical reports and specification for 3GPP technologies, and it consists of 7 SDOs worldwide. It's called standard defining organization. So it includes organization from like USA, Europe, Japan, South Korea, China, and India. And there are 3 main project groups under 3GPP, namely radio access network, services and system aspects, and core network terminals. Uh, then there are 16 different working groups uh, under 3GPP. So these 3 project groups are categorized into 16 different working groups. Just a minute. Yeah. So there are 16 working groups under these 3 main groups. We have something called releases. So each release is like the phase where the functionality of all protocols of the user, and they are ready to implement. Uh, yeah, and then so each working group has like a specific task. So for example, for our core network perspective, we have group called SA. So under SA there are several working groups, and there is another project called CT. It's called core network and terminals. Again, we have a different working group under core network terminals. So under SA, we have overall architecture and service capability for 5G system. And can you someone is on mute? Can you please mute yourself? Then under core network and terminals, we specify the interfaces and the capabilities. For example, in working group 2, we specify the system architecture for 5G system. Then under core network terminals, like work group 4, we define different protocols which are used in the core network. So this is the overall idea. Then why the understanding and reading of 3GPP specification is a challenging task. So basically, there are so many technologies that are covered by 3GPP, which is from GPRS, GSM, UMTS, Edge, LTE, then 5G system currently. So it's quite it's a wide range that are covered by 3GPP. Then we have again challenge to select the right specification, because there are several specification, and we should have the global knowledge which specification we have to follow. Then some specifications are very big, like for example, if we go for the specification of RRC, it's beyond 1,000 pages. Again, the each specification is interlinked, so if we start reading, you will see some references which point to another specification. Then that specification again might reference to some more specifications, so they are interlinked, so it's quite challenging to follow all of them at the same time. Then the last challenge could be like the normative references, which are not much covered in 3GPP specification. They give some example, but it's not the complete end-to-end use cases that are described in the 3GPP specification. So these are some of the challenges which which comes while we read or understand 3GPP specifications. So how we can tackle these challenges? The first thing is you should know what you have to read. So when we open any of the specification, we have some numbers like 523501, 23502. Then again, we have some mantissa like V or S. So they have the specific numbering. For example, the first two digit they specify the series of specification, and the rest of the digit they specify the part of the specification series, that is series number. So for example, here the 38 series is dedicated for new radio, and 23 it's for the stage 2 of technical realization. Again, if you follow the sub number, the 413 is for NGAP. Similarly, like 501 for 5G system architecture. Similarly, 502 for the procedures. So on the left hand side, I have given a screenshot from the 3GPP website. So here they have categorized the different series between the different 16 working groups. So you can follow the links, and if you click the particular series, you will see the list of all specification under this series. So you can follow the links below. Again, there are some mantissa. So I have mentioned the important mantissa V. It stand for version or something called release. Uh, then there are some blogs also that you can follow. I have given a link here also, so you can see the more mantissa. So I have covered just the important mantissa over here, which we will require here. Again, like here are some of the important specifications that you can refer when we work with the core network. So each specification they talk about the either maybe the procedure, overall procedure, or the protocols for the different components. So for example, the protocol between user plane and control plane, it defined under PFCP, that is 29244. So we will see some of the examples between this protocol. Then there is an SSF which deals with the slice selection for the UE. So it is again defined in 29531. Uh, Another practice could be read respective specification first, then we can go for the references, because if you see the references and then again they are interlinked, so it will be confusion. So to avoid confusion, we can have a global overview of a specification that you want to uh, have some idea to implement. Then we can see the respective references, so it will avoid confusion. uh, yeah, then this thing is like important, like you should have some example scenarios in your mind. So when we so you have studied some of the procedures, and now you can search for related tutorials. There are some video tutorials, that could be small white papers by industry. There are some wide range of blogs also. Again, there are some websites which provides the short notes or maybe the call flows that are specified in the specification. It helps a lot because when you read from the specification and you have idea of how it is implemented in real world, like what are the use cases and scenarios, it will be good to you get a good motivation to follow it. uh, it's not necessary, but whenever it's needed, you can take a printout of some of the main important pages of specification, because the visuals make good impact when to grasp new things. So it's better, not always, but it's better to have some drawings to replicate whatever we have studied, make some notes. Again, it's important to ask your subordinates. uh, of course, you have studied a specification, you have gone through some notes, blogs, and it's important, like you discuss with your colleagues, forum. Uh, it will help a lot to revise or correct yourself what how you perceive the specification. So this is about just overall global overview of what is 3GPP specification, what are the challenges that occurs. Uh, Again, I have not covered all the aspects of how the 3GPP works and how the technical specifications are produced from the technical reports. So we have just taken a global overview, what is the specifications and what are the challenges and how we can follow some recommended practice to understand a 3GPP spec very better. In the second part, we will see now the how we can implement some of the procedures and protocols from 3GPP specifications. So it could be like we can saw some call flows from 3GPP specification. Then we can implement by doing some UML diagrams that is the well practice opt during the software developments. And then we will see like how we can start like to encode or decode a basic fundamental block that is called information element. So we will go like a very global overview, and then one by one we will start to see some specific task. So before moving, like let's get some overview like how 5G core network communicate between different components. So so we can categorize in two parts. So one is the communication within core network, like within different network functions, and the communication outside core network. So so the 5G in 5G system architecture, like we adopted the cloud native principle. So 5G system should support cloud native objectives. So keeping in that mind, so we have come up with something called SBI. It's called service based interfaces. So it's a generic interface that is not like the protocol specific or binary brace. So in SBI, what is there is like we use TCP at layer 4, and that then at application layer we use HTTP. So it is the way of mediator between the mediator for exchanging message between different network components. And above HTTP we use serialization with a JSON. And then we use a different data models. So again, those data models are standardized. So it's called Open API. So it defines what is exchanged between two network functions under SBI. Again, to communicate with external, like for the communicate with the external component, like for example with a user plane. So we have a specific protocol. So we still have the reference based architecture to communicate with a user plane. Currently, we don't have a service-based architecture for communicating with user plane. So we have generic protocol which are coming from previous generations, and those are evolved with time. So for example, we have N1, N2 reference points, so which uses the NGAP and NAS to communicate with radio access network, and below we have SATP. Then communicate with a user friend function, we have PFCP protocol. Uh, Again, there is a GTP1U, which is not again part of core network, but it's a communication between radio access network and user friend function. Again, like this protocol, as we said, they are not like uh, they do not follow the service based architecture. So this protocol has its own serialization techniques. For example, for NJP, it is encoded with ASN1 serialization techniques. So we will not see all of the stuff. We will just try to focus the simple protocol. Like so, we will cover PFCP protocol in this webinar. And if you people are interested, and might be we will see the further another protocols like NJP, where we have the serialization with ASN1, and maybe some of the protocol from southbound interface, that is SBI. So so this is about the communication mechanism in core network. So So we have the specification 23502, which we specify all the procedures which involves in the core network, and again the communication with a radio access network or user plane. So for example, in this slide, I have included the general registration procedure. So what we do is like we get a thorough knowledge of the procedure, and then we can select, like for example, one by one we start to implement the procedures. So what we will do, we will take overall idea of what is registration procedure, then we will pick one message and we will see how we can start or how we can map with our coding environment. So I will just so I have just opened the specification like 23502, which describe the general registration procedure. So I will just quickly take overview of the registration procedure, because we will not go in deep to the each and uh, every procedure. So here we start with the registration request. So it is assumed that the RAG procedure is done. So we have done the all synchronization procedure. The RAG procedure is done. RRC setup is done, and we have received RRC setup complete message. And then what happens is like the Gnode B triggers the registration request towards core network. It does the AMF selection based on criteria, and when AMF receives the registration request, it comes with the initial UE message, which has the RRC establishment cost. So uh, if there is an old AMF has associated with this particular process, then what new AMF does is retrieves the context from old AMF. So we can see the NMM context transfer message, UE context transfer message, and it requests the identity request to get a SUSI via NAS message to the UE. And when we receive the identity of a UE, that is the SUSI of user equipment is now at a new AMF. It selects the authentication server, that is AUSF, to further perform the authentication process. Uh, so during this, like it's a problem solving process. Like we get authentication vector from AUSF get it from UDM, and then we get the AMF asks for the identity request or authentication request, and the challenge is solved to authorize UE in the network. So when this process is done, uh, so NAS auth request and response is done, then there is a process of equipment identity check. So again, we will not go in deep with that. So once the authentication is done, then AMF selects UDM and obtain the subscription information. So the subscription information is related to the access and access mobility, and maybe the again SMF subscription related information. So once it is done, the AMF sent a registration accept message to the UE. In response, we have the registration complete message. So in which we can have again the piggyback message called produce session establishment. So it is not necessary. So we can have it. Uh, so we will not see again in detail. So for example, if UE has triggered service request, so it's a different message that UE triggers the service request. Then what happens is like AMF create the SMF context, SM context with SMF, and we perform the UPF selection. So for example, if there is an anchor UPF that is already established, so we inform the anchor UPF like uh, the based on UPF selection criteria, and we create the session establishment with the UPF. And in this way, we create a session with the UPF. Again, we inform anchor for the dropping with to buff to send a buffer traffic with the old UPF. So we'll not go in a complex scenario like where there are multiple UPF. So we'll just consider here like there is only one UPF in a picture, and we don't follow or like the modification with the old UPF. So we can just we can just focus like there is only one UPF and we can have the session with that UPF. So again, go back to our presentation. So let's see, we have selected the message, the session establishment request that we have to implement in the code or in our components. So what is important to do is here is, so you see like we have the message, but we don't have the exact content of message. So we have to see the respective specification perhaps, or maybe we have to see the overall the description of the call flow. So what is the first thing that you have to do is, like when you decide to implement a particular message, so get the get all contents of the message. So it's the process like we create a detailed call flow. So we have selected the message. For example, we selected message session establishment request that we want to implement. So again, the content of this message is it's specified in standard 29244, that is Pfcp protocol release 16. So you can see like in the table, we have the table like what are the all information elements or the message contents of this PFC session establishment request. And then what we can do is like we can create a simple call flow and we can mention all the corresponding contents of the message. So it's the first step that you do, like you create a simplified call flow. So there are a lot of tools online available. You can use that, or maybe you can use the traditional tools like slides or power presentation. So first step is to create a detailed flow. So here you will get idea like what are the message content. Then the second step is like you create something called UML diagram. So UML class diagram, it's consists of three parts. So you can see there is a column with a three row, or you can say a table with a three cells. So first we specify class name. So we like procedure we define as a class, and in the middle we define the different attributes which belong to this class. And in third we define various methods. So for example, if you take example of session establishment request, so there are different elements. So we will go in deep. So we have different information elements. So what we can do, like we can organize them. So you have something here like a plus sign. So it denotes this attribute is public. So its scope is public. Then we have a colon, and we define the type of this information element. So it could be anything like you decide by yourself. So you can see some of them like I mentioned with underscore t. So the in OAI code, like it's a basic information element, so we don't create class for it. We can define it with a simple structure. Maybe there are some information element, they there is again group of information element. For example, it's a grouped information element. So then we can create another class. So you can keep in simple thing in mind, like if there is a group element, group information element, we can create a class. And if there is a simple structure, we can avoid a simple information element, we can avoid to create a different class. We can just specify with a structure. So again, there is something which is not standard with UML. I have mentioned something called M, C, and O. So these are the it stand for mandatory, C stand for conditional. So there should be some conditional condition, then this information element is present. And then there is something called optional. So at OpenAirInterface, what we do is like we first implement the basic version of any protocol or procedure. So we don't implement all conditional or optional information element. So we implement the all mandatory element first, and if required, based on our roadmap and the strategies, then we can go for the conditional or optional element. So in the code, you will see a lot of code might be commented out. So it's because we just follow first mandatory information elements. So this is about overall what is a UML class diagram. So again, this is for the one information element, but you can see like the information element session establishment request. It consists of simple information element, then there are again group, some of the group information elements. So That's why it's important to have a overall UML diagram. So I will quickly go like how it is done, like for one of the message, like that is session establishment. uh, okay, so I will just zoom. So okay, so here it is, the message that we seen. So we have now idea like how it is come, like what is mandatory field, what is conditional field, and what are the optional fields. So we take this from specification, then we decide whether it's a group of information element, then we can define as a class. Otherwise we can keep it as a simple data type like struct. So what we can do, like we can create a flow chart. So for example, the session establishment, it consists of the group information element, let's say create url, it's called, or create far. So we can define it again we go to specification. We, for example, we have saw for example, like this, we see in a table what are the elements. We specify in the attributes section, we specify it's mandatory or conditional or optional. And then we specify the methods. So I have mentioned like the generic methods, get or set. So for example, it could be get node id, set node id, something like that. We can have more methods also. So it's again implementation specific, like how you want to implement. So this is like a recommended practice. So it's not important, like it's not exactly what you should follow. You can also specify your own methods also to handle the information elements. So similarly, we specify every group information element. So if you see again, now we can, if you see globally, like for example, session establishment, we have different information element which are grouped of independent information element. So we specify it. And if you see the last leaf of any of the UML section. So here you will see like now we have the independent information element. So for example, if you see the data type of the information element, those are like primitive data type. For example, integer, it could be the inet data type, like the IPv4 address, IPv6 address. So these are the simple information elements. So where we don't need a different class, because we can directly assign values, or we don't need a separate methods to assign or retrieve the information. So we can keep it as a simple structure. So this is important because now you have the global idea, like when you implement any of the message, what is it's a content of a message. So again, here I have not included all of the information elements. I have included all of the grouped information element for this particular message, but not all individual information element, because there are a lot. So we can create different copies of UML diagram. So where we can, for example, in one we can specify for one of the grouped IE. In second, we can specify the second of grouped IE. So this gives the overall idea, and we will not miss any of the information element. It is important because when we say it's your product is a 3GPP compliance, so we should handle all mandatory or the corresponding optional elements. So we should be very careful about the data types also, because otherwise it will not be compatible with a different device which also follows the 3GPP and they implement the procedures. So again, this is like a standard way, but we can have like different methods also. Again, we go back to our main presentation. So again, quick overview, like we have seen overall like registration procedure. Then you decide you have to implement one of the message. So what you do is you create a detailed call flow of that message. You specify we specify the content of this message. Then again, we go in more detail. What we do is like we create a UML class diagram, and then we create overall UML diagram for this particular message. So we have the global idea, what are the content of a message. Yeah, so again, like we follow the table from specification. So this is about like you have now you have the idea, you have created UML diagram. So now it's time to write a code and implement it. So before going deep into the overall code structure or overall the coding style, I will what I will do is like I will give a brief overview of how OpenAirInterface core network repository are organized. Are organized. So so if you open any of the repository, so we have different components. So you will find the generic structure. For example, we have the build directory where it is used as a CMake build directory. It has also the instruction to install the network component on bare metal. So again, you have seen in tutorial, we have something like build install and then maybe build with option like verbose and the mode like debug. So all these scripts are installed are included in build directory. Then we have CI scripts folder. So in this folder, we have the scripts for used for CI/CD validation at Unicom. Then we have a Docker folder, which includes the Docker file for Ubuntu and the Red Hat based image build like Podman. Then we have folder called docs. So where we have the documentation. So normally it consists the feature set. So what are the all feature that we have implemented currently and what are not supported or maybe we plan to support. So this is not the only thing about documentation. So we have wiki also. So if you go to any of the network function, so I have given a link below. So for example, if you go to AMAP/wiki, you will see the wiki page where we describe the information about configuration and the information about the little bit information about the code and what are the again what are the features which are supported. So you can also take a look at the wiki also of each components. So from then after documentation we have etc folder. So we have the configuration file to run the network component. So we set the environment variable, and then we have the script. We can have some initialization scripts. It's called entry point also. So which initializes the environmental variable for the cloud-based deployment, etc. And then we have the actual folder SRC, which implements 3GPP procedures and protocols. So so if you open any of again or any of the repository of the SRC, so you will see the protocols which we were talking about like NAS, NGAP, PFCP, or GTP1U. So these are we have dedicated repository for it. So we'll find out the implementation of those protocols in the respective repository. Again, if you see the network function name underscore app, for example, AMAP app or SMAP app. So here you will see the all 3GPP procedures that we implement. For example, if we take AMAP, so all procedure related to N1 or N11, those are implemented in corresponding modules. Similarly for SMAP and AUSAP and the rest of the components. So under this app folder, you will see the procedures. Uh, then if you go the src/common folder of any of the repository, you will see some files which start with 3gpp underscore the number of specification. So what these files includes, it includes the common data type or common information elements. Then there are some enumerations that we might need during the implementation of procedures, some constant values that we use during procedure. And again, if you see OAI underscore the name of component, so there are two folders. You don't get confused, like the name and for example app folder, and there is a OAI underscore the component name. So in app we have the procedures. Then if you see OAI underscore the component name, for example OAI NRF, so here you will find one generic file. It's called main.cpp. So it which invokes all the procedures. So here is a starting point for our network function. So you will see these four or five kind of messages here. So what we do initially, we pass all the config parameters. So and then we display it. So whenever you start OAI net function, you see some of the logs of the default configuration parameters. So we do first the parsing of config parameter from config file, and then we display on the screen. Then we initialize the application layer. So this is the main layer which invokes different 3GPP submodules. And then we invoke the thread manager. So currently you will see there is either ITTI or a task manager. So we have seen about ITTI thread manager in last tutorial or webinar. So you will see something called task manager. So it's a boost based boost library that we use to manage different threads. So you'll see either ITTI or for simpler low number of tasks, we will use task manager. And then we initiate HTTP server to expose the uh, southbound interfaces. So I will take a question later on, maybe, or if you have a question, you can put on chat. Some of my colleagues will answer you. So this is about the overall the structure. Now we will see one of the example, like let's see how we can. So we have now overall idea. So we decided our motto. We decided one of the message to implement. Now we made UML diagram. We have overall idea of how OAI code is organized, and now we start to write a code exact actually. So for example, we take example of Pfcp protocol. So let's let's take a quick recap. What is a Pfcp protocol? So it is an interface between control plane and the user plane nodes. So it's used in 4G and 5G also. It's defined in technical specification 29244. So in LTE it's called SX interface, and in 5G we term as N4 interface. It is UDP based protocol, and it uses standard INA port 8805. Uh, on right hand side you will see like how the packet is processed in these protocols. It's a journey of packet with the protocol. So what happens first is like we have something called session. So in session we have like the rules about matching of the packet, and then we then this session uh, again point to some of the action rules. So for example, you can see there are MAR, FAR, QER. uh, so so we have the rules to what to do with the packet. For example, if you want to forward, we will see the FAR, forwarding action rule. If you want to implement a quality of service, we will see QES. If you want some metering, we will see usage report rules. So if we summarize here, so this protocol, it's something similar to OpenFlow. If you are familiar with OpenFlow also. So we do two things here. We do the matching of a packet. So for example, we see different header fields of the packet. Once we do the matching, we apply some of the action set. So this is about just global overview of what PFCP protocol is. So then, uh, so this is general format of PFCP message. So you will have the header, and you can have one or more information element that we saw earlier. It might be a bundle message also. We can have multiple PFCP message. Those are piggyback, or maybe we can have PFCP message with multiple information elements, as it is mentioned. So generally, there are two categories of messages. So one is a node related message. So where we specify the how to interact between two different peer nodes of PFCP protocol. So for example, we establish association with a node. Then we can update the association. We can have we can remove the association. So so these are like how the two PFCP peer can communicate with each other. or establish a connection with each other. And once we have the association with peers, it's done, then we actually send this the session related message. For example, as we have seen the session establishment request earlier. So you will see these are like, for example, I mentioned earlier, we specify the constant or enumerations in the src common folder. So you will see this kind of uh, the the enumeration or the definition in under the src common or 3gpp 29244.h header file. Yeah, so this is generic pfcp header. So for example, here we have something called flag. So it again have some bit information. So it has some, so it has a meaning. For example, s is stand for session. So if you have the session bit enabled, for example, if you see on right hand side, if the session bit is enabled, we can see the information element called session endpoint identifier in the message. For example, here it's a 0, that's why we don't have the session related information element. Then we can have the bit for mp, which talks about the message priority. Then we can have follow on bit, like for example, if there is a bundle message, we have multiple pfcp message, then we can have the follow on bit set. Then there are some bit are intentionally set as a spare, and then we can see the version of this protocol. So we can have the 3-bit dedicated for it. uh, so this is the generic the header structure of pfcp protocol. So it is important to note, like the flag byte, it notes like what is the content of or what are the conditional content of this message. Again, we will see the detail example. So for example, we want to write a header in our code. So what we will do is like we create a class, and we create attributes with the information content of the message. For example, we have the 8 byte of flag. So what we do, so we have to set each element, we have to retrieve each element. So what we can do is like we can create a union of 8 byte, and then we set the bit, for example, s for session. Then for message priority, we set 1 bit. So for example, this is so we have missed the follow on bit here actually. We can set 1 bit for a follow on. So this is the earlier implementation where we have like we have not bit set for the follow on, but we can have 1 bit for follow on. We can have spare bits. Then we can reserve bits for version. Then we can then again we can for example, we can see the message type. So you can see the message bytes is a 1 octet. So we take it as a unsigned integer 8. Then again, for the message length, it is denoted by 2 bytes, so we use unsigned 16. Then similarly for session id, we have 8 octet, so we use unsigned int 64. And similarly for sequence number. And then for the again for message priority, we use union. We have 4-bit reserve for as a spare, and then we can use 4-bit to denote the message priority. So now you can recall that we are going as a UML diagram. So we have defined some of the attributes. We define their message, like we define their the data type also, and we define a class. So now the next type is we define the methods for this class. So we can have a generic method as we seen the set get method. For example, set session id, get session id, set message type, get message type, length, then the sequence number. So we can have a generic method to get set. And apart from that, we will need 2 more methods. So you'll also see something like load from and dump to. So as we know, like as you recall in the protocol slide here, they do not recommend the standard serialization technique. So we have to write a code to serialize input stream, whatever we receive on UDP socket, and then we have to dump it also, or write to the as an input stream when we encode it. So you will see something like is read. So it is a standard input stream method to write to read the input stream. So we have received byte stream on UDP socket. So we start uh, decoding it. So first we decode the flag byte, then message byte, length byte, and then as we see like we will decode some of the information element, some of the content of information is optionally or conditionally. For example, if the session bit is set, then only we will use the decoding of that information element. Similarly, for sequence number, if it is set, then we will read it. Again, you will see something like to conversion of byte order to network order to host order. As you see, it is like MSB is here, so it is in network byte order. So we will convert it into the host bit order. So similarly, you will see another method dump to. So the difference will be only like instead of this input stream object read, you will have output stream object the write function, like it's called dot write function. So this is about like how we can code a simple information element into the code. uh, yeah, so this is about the, so we have seen, we can see now the actual information element. So we have created a class for uh, generic header. So this is a parent class that we will reuse. Then we have let's say how to write the actual information element. So let's say we have to write a node id. So what node id includes, it includes the generic tlv information type and length. And then we have flag byte to denote the node id type. So it is a decimal value it can take, and each decimal value has its the meaning. For example, if it's 0, then we have the node id value of ipv4 address, 1 for ipv6 address, 2 for fqdn. So what we can do is like yeah, so we create a class pfcp node id again. So what we can do, like we create a union for a flag where we have spare 4 bits. Then we can have 4 bit for node id type, and based on that we can have like either the node id like ip4 address or ipv6 address or fqdn. So again, we have this generic method load from. So we read the flag byte first. So here we are decoding the information element node ID. So you see it is it will be followed like a same structure. You define a class, you define method to serialize it or deserialize it. So you have received node ID. So you decode or deserialize the flag byte first. So here we deserialize a flag byte, and based on flag byte we will deserialize the content. Like for example, if flag byte is node id type, it is set, then we will read the, for example, we have the mechanism to read the ipv4 address. Similarly for ipv6 address, and we have mechanism to deserialize uh, fqdn. uh, so let's recap everything again. Okay, so as I told, like we have the generic structure, builds, yeah, script, Docker, etc. Then we go to SRC where we have actual 3GPP procedures and protocols. Here you can see there is a protocol PFCP, NGAP, NAS. So it implements the protocol. OAI SMF is something like the generic main.cpp file you will see. Then SMF underscore app, here you will see all the procedures implemented like N1 and 4. So this is the generic structure. So we will go like, for example, let's start main.cpp. So as I told, you will see generic structure in all network components. For example, you pass a component, then you load all the parameters, you display parameters, then we start a thread manager. So for SMF, we have used ITTI, and then we initiate the SMF application layer, so which invokes the different 3GPP procedure modules, and then at last we initiate the HTTP server for service-based interfaces. We will again, since in some of the webinar we will try to see what exactly it is. So we are interested here, like it invokes the 3GPP protocol. So we go to definition. So SMF app invokes different 3GPP modules. So here we are interested in N4. So we will see where is the N4 is instantiated. So we'll see here the SMF N4 is instantiated. We will ignore other parts. So again we will see what is there in N4. Okay, so it's taking time. Let's, oh, it's done. So you will see on N4, so we have the Pfcp messages. So we inherit one parent class called Pfcp layer full stack. So if we see what happening here, so okay, so now you will see we have started the UDP socket. So here actually we will see the packets from lower layer, like we'll get the packets from UDP. So it has a different mechanism. For example, to get a packet or start receiving packets. Uh, yeah. So yeah. So here you will see different methods. For example, under UDP application, you have a method called handle receive, which receives the package. So it is a virtual function. It is defined in the derived class. So we will see uh, references, and we have to see the definition in the N4. So you will see here we have the definition written in N4. So now you receive packet on UDP socket, and it is now at N4 application layer. So now actual decoding starts. So you decode the input stream, you create the instance of PFCP message. And do you recall something? So as we seen, like load from is a method to deserialize the message, and dump to is the message to serialize the message. So now whatever we have seen till now, it starts from here. Like, so you have received message on UDP socket, you called the derived the definition in the deserialize sorry. So you call to the method which is defined in derived class, and you start decoding. So if you go to load from, again here you will see the class, generic class PFCP header. So we have seen as in a slide, there is a generic PFCP header class. So here you will again we deserialize some of the information. So for example, if you see again here, so here you will see, okay, so normally in the load form of message header, you will see generic information like what is the length of message, what is a type of message. uh, then when we have the actual content of message, that is length and type, we go to okay, so what I will do, uh, so we will see what is okay, so we'll go directly. So just to recall you, so we called load from, and then here you will see we have called the PFCP input stream method. And now here you will see all the cases where, so first we invoke a PFCP parent header class, and in header we get the type of message. For example, it's a standard PFCP message or information element type and length. And now based on each for example, we can have different method, and based on each we can see we can do the decoding of message. For example, if we see the node ID, so it's called the definition of node ID. Okay, so now we have come to the whatever we have seen into the slides. Okay, so just let's recap again. What we have seen in the code is like we have take a global overview of main.cpp, where we instantiate the application layer, and in the application layer we instantiate the n4 task, and under n4 we have instantiate UDP socket. We receive on UDP socket, we call the method the handling method in the derived class. In the derived class, we saw a content of message and we start to deserialize it. And again, this is a generic handling of information element, like we deserialize the flag byte. Based on flag byte, we see if it is a IPv4, we will deserialize IPv4. If it is IPv6, we will deserialize IPv6. And it's done. Like for example, now we will, if you see the, and then we have handler for this message. Like, so we receive message on N4, we deserialize it, we get the content of each and every information element, and then we handle it. So this is again the another part, like what to do with that message. Like for example, if you have received node ID, what to do with that? Or for example, if you have received the Pfcp session establishment response, what to deal with that? So it will be handled by this generic method Pfcp receive PFC, handle receive Pfcp message. So we'll not go again deep into that. So let's again go. Yeah, so we have seen like how this realization of information element is done from the beginning. So this is about the single information elements. Like for example, if we have just simple information element, just a few couple of attributes, there could be a message where we have, like for example, we have seen in session establishment there are several information elements. So we can do like we have generic method called add information element. So we handle in similar way, like we invoke the method parent method Pfcp header. So we get header information, and then we set a message type and we iterate for example, for example, if we have node ID as a element, we will decode it. Again, we, if for example, if it is session establishment message, then we can have create PDR, create far. So similarly, we can decode multiple information elements. So this is nothing but group information elements. So this is about uh, how we can follow the code. So I will try to summarize what we have seen. I hope it's not too fast and too much heavy for you. So I will just recap. So what we have seen here, we have seen a short overview of 3GPP specification for 5GCN. What are the challenges included in the reading and understanding the long or lengthy 3GPP specification? What recommended practice you can opt to understand 3GPP specification very effectively. Then we have seen how we implement at OpenAirInterface core network group. So we have, like, we create a basic UML diagram, basic call flow. So globally we create a big like globally seeing, we create a call flow. Then we go to UML diagrams. From UML diagrams, we come to know like what are the different information element, what are mandatory, what are optional elements. Then we decide whether we use a class or struct. You can use any mechanism based on the language you choose. And when we implement it uh, in an OpenAirInterface stack, and then we have seen like the example of encoding and decoding of information element. So here we have seen only encoding, like we have all the time we have just seen load from, but the only difference is while decoding, sorry, while encoding, you will, instead of load from, you will use dump to. So instead of input stream read, you will use input stream write method. So this is it. So what I will do, like I will try to take some of the question. I have not seen chat. Yes. Thanks team for answering questions. I hope it is clear for all of you. So again, we will share the slides after the webinar. Again, we have not
Rahul,
covered. Yeah. Yeah, please.
can I ask it out directly? If it's you don't mind.
Yeah, yeah, sure.
Yeah. Can you tell us how to generate the UML diagram? Like which tool? Any free? tool, open source tool that is there, where we can give input and like mainly from in general any protocol, take it ngap or rrc. Generally we work on the ran side. So for rrc or ngap or any protocols, any tool is there, any open source tool is there where we can generate from the 3D
So
slide the UML diagram.
so like for me, I haven't used any tool. So there are tools like Lucid Chart and other tools also. I personally I haven't used any tool for the moment, but maybe if any of the people like Thin and from people from RAN, they can answer this question. But for me, I haven't used any open source tool for it.
Okay, then how the session? I mean, what are the message you showed us, right? At least can you tell how it was generated so that we can, if not a tool, any procedure or for the session PCR session establishment, you showed the email diagram, right?
Yeah. So what we do is like we take a specification. For example, this one.
Yeah, that will be helpful. Yeah. Okay.
Yeah. So what we do is like we take a specification and we list all the attributes of that. So for example, there are some information elements which are grouped together, and some of the information elements which are just independent information element. So what we normally do here is like we like the simple independent information element we define as a struct. Again, it's not a standard UML procedure. So here we have specified like underscore T for simple information elements. And if there are a
Yeah.
group information element, we use an independent class. For example, create far is again grouped of several information elements. So we define uh, a separate class for it.
Okay. Okay. I think my
Again, we
doubt is
don't
like
follow standard.
yeah. I mean, I got. I think you understood the question in a different way. Can you go to the next slide, which shows all the, I would say, the UML diagram, the previous one, sir, not this
Yeah,
one,
yeah,
the big diagram which has all the
yeah.
UML diagram which shows, yeah, this one. Yeah, the question is how you have generated this UML diagram. Yeah, from coding point of view, it is okay, but from the representation, because in the specs it will be in table wise, and we have to go to the particular sections and see individually, right? So seeing in this
Yeah, yeah.
view, obviously, will be a holistic view. So, I'd like to know how you have generated this particular diagram with the
Uh,
mapping of all. Hmm.
so normally I have done it manually actually. So for
Oh,
example, yeah, so
but
I haven't used any
but
tool.
it takes a lot of. Oh, okay.
Yeah,
But
it takes
manually
time.
it takes a lot of time, right? Yeah, I mean, it is a okay. I thought because the
Yeah,
box, the way you presented it, I thought it is generated from some tool where you have given input some mechanism of 3GPP or some table or some object, generated object. I thought then that's why I asked. If it is
no.
manual, then
Actually,
I
I
have
haven't.
done.
I haven't. Yeah, I haven't done it.
Great.
But it's good practice to use some of the tools that are available.
Oh, okay.
I tried some of the
Okay.
tools, like there is a Lucid chart also, which creates a YAML diagram, but it was quite how to say,
Okay.
not that much interactive for me. So I decided
Oh,
to do some because uh, yeah. So because for this presentation, I
okay.
have took
Oh, okay. Got it.
one of the simple
Okay.
message.
Okay.
Yeah,
So you had I think you might be done. You had done it using PPT then, if it is manual thing, either PPT or I mean PowerPoint or Microsoft PowerPoint or sorry, Word or something like that, right? In for the table
yeah. It's
creation
also
and all.
yeah. So it's done in Google Docs. Just
Google
takes
Docs. Okay.
yeah. Yeah. Sorry, it's not the best practice, but
Yeah,
yeah,
okay. But anyhow, yeah, at least for session you want to show us in a holistic view. Thanks for that. Thanks for your
yeah, yeah,
spending the time on that. Oh, okay,
yeah,
Rohan. Thanks. Thanks for answering the question.
yeah.
Hi, I have a similar question for the UML diagrams. Are those publicly available anywhere that we could see those?
So normally we have not documented all the UML diagram. For example, like I started to do it for NSSF. So for example, if you go to NSSF, we can see it. But for rest of the components, we have not yet done it. So Eventually we will do it for the component, like when we document it, and we will try to either mention it on the website, or for example, if we go to NSSA, you can see the PDF file. Normally I have attached a PDF file. So here you can see, like for example, yeah, so we follow the same procedure. We take a call flow, we make a generalize a detailed diagram, and then we try to, for example, yeah, so then we try to write a small UML diagram. So it's not done for all the components yet. So eventually at some point of time we will create for the different components. Yeah, so the answer is no, we haven't documented yet, but we will do it eventually, and we will try to either put it on docs folder, or maybe under wiki page. This one, it will be available on the webinar page. Is that fine?
Yes, thank you.